Hello and welcome back to another Advent of Code video. So this episode we are doing day 21, getting close to the final thing. Not 21? No, 22. There's some cache busting to be done. I've finished day 21. So we're doing day 22. So this one, I've done a bit of prep work for it, but the gist is that you have an input of a map-like structure like this, and then a set of instructions, and you always start in the same place. Well, depending on where the map is, you start in the top row on the leftmost dot that you can. Which this should say it somewhere. Yeah, you begin on the leftmost open tile on the top row of tiles. So I believe we get that right, but could check. And then you kind of have a notion of you're facing one way, so you always start facing right. So we're facing, there's a better map. Yeah, we're facing that way. And then we kind of follow these instructions. So we go 10 to the right, then we go 10 steps, then we turn to the right, then we go 5 steps, then we turn to the left. And overall, we kind of follow this thing here. Where does it go after this? Yeah, I assume that it kind of works, but we go 5 and then we turn to the left, and if we're facing that way, to the left is anti-clockwise, I believe they said. Left is counterclockwise, sorry Americans. So counterclockwise facing down would not be that way, it would be that way. So we'll turn into this brick, and then we do another 5 steps, we can't go anywhere, and then we turn right and we go 10 steps. So here we should wrap around, so we just do another 10 there. And then we turn left again, we can't go anywhere, right 5. Yeah, I feel like there's something missing there, to get from here to there. Though, is this, yeah, this isn't showing the full map down there, oddly. There's some missing stuff there. So we go down, yeah, we go down, and then this is interesting actually. I just want to actually come out of here and go into Chrome and get rid of all these things. Doing hotkeys in the host system using i3. And so if we go to Advent Code, and what are we? Day 22. 2022, day 22. Yeah, so this one actually has the dots. That's a really weird rendering bug, I guess, in Ladybug. But yeah, so basically we go down, we go here, and then we wrap around. So we hit the edge and we wrap around to there, then we go down, then we go there, then we try and go down and we wrap around and we go there, and then we turn to face this and we stop. And this one, which is highlighted, which I believe it is highlighted in there as well, is our final spot. And depending on where we are is the answer. So I've got quite a lot of this coded up. So yeah, a couple of 100 lines of code. Couldn't sleep. I got some job things going on at the moment, and so I thought I'd do some coding instead. So how we do this, we parse in all the lines, and we kind of build the grid. So we have a grid, which, where do we have our grid? must have skipped over it. Yeah, so our grid is basically a 2D array of cells, and a cell is either outflow, wall, or unknown, and I only did that just so I can yield something there, which like potentially I could just yield anything there, but that's alright, because yeah, you can't like just have a never and an else, which yeah, I don't know, I would like it. Yeah, so when we parse it, we basically build that thing. You can also print it out, and you can pass in the position where you are, and it will print it in bold, so we can see this little thing here. And we can get the first one, which, yeah, it checks for the first floor in that top row. And the next is what I haven't done, which is probably the more interesting thing for a stream. We have a notation of instructions, and when we execute them, we do some stuff. And this, I realise we do actually need to return a position, and we can probably just do this. Just some stuff that I did this morning, but didn't commit because I was going to do this video. And so what we can do here is yield a position, and here we can also yield a position. Yeah, and that's basically returning the new position that we're at, and here we would go position equals whatever that is. Yeah, and I made like a iterator for the instructions, so we give it that instruction string, this thing here, and it basically sees whether the next character is R and an L, and if it is a rotate instruction. Otherwise, it will build up a number, and like even if it's the last one, it should still work out that's a 5. And to do that, that's like you basically get a byte at a time, times it by 10 when you get a new one, and add it on. That's just how you do it. So how this goes at the moment, if we go 22 and maybe just an example, I think we even like print it out, I can't recall. No, we don't. But what I could do is like maybe print line, right, we abort because yeah, we've got unimplemented stuff. But yeah, we can go like grid to string and pass in the position, and if we do that at every time, it should kind of just print everything out, but it probably won't in this because we've got that unimplemented, but we can see how far we've got. So build day 22, and I think we just haven't got far at all because we haven't implemented anything. So I've got some things on how to work out what is happening. So I guess what we want is we want x to be position dot x and mute y equals position dot y. And these are U sizes, and potentially an instruction, well, potentially based on our direction, we might be going negative, and you can't go negative in U sizes. So what I think I'll do is actually add 1 to here, but then after a bit, we can subtract it off. And here we can match on position dot direction, and if it is right, we can go x plus plus, so we want to go right. If we want to go left, we can go x minus minus, and so this could underflow. we don't really care if we go over the bounds of the grid just yet, because we'll check for that. But we can't really check for this underflow without adding like a bunch more code to this, which it looks a bit nicer. Just like those 4 lines like that. And so here, if x is 0, so before we subtract it back off, that means we would have overflowed. And the same for y. And if y minus 1 equals dot grid dot size, that basically means it's overflowed on the far end. Or if x minus 1 equals the current y dot size, that means we've overflown on the row as well. Well, one's overflown in the vertical space, and one's done that. And so if this happens, maybe we can just go panic unimplemented grid next and wrap, because we'll need to implement that. Otherwise, we can subtract off the x's again. And here we want to check whether dot grid y x, and so we don't need the minus 1 that we had up there anymore. And if it is not floor, wall, sorry, I'll move the mouse. If it is a wall, that means we can probably just return none, because that means we've done that. But also, if dot grid y x is open, I think that's what I called it, and I think it might be an uppercase. Out is what I called it, and I'm not in, so I can't like just jump back. So out, and this can probably be wall. So if it is out, we also kind of just want to do this panic there. And that is that. Otherwise, I think we've just done it. So we would want to just return that. So we've got some panics, which will come up very shortly. And direction will remain unchanged. And so we just return our new thing. And yeah, so this is kind of what we need to do. I'll just add those comments there, and maybe take away that to do. So now we should, it's kind of interesting. So I changed position from a struct to a class, and the reason I did that was because I wanted to kind of mutate it in the next, and in fact, even there, I wanted to mutate it and not have this yield, but I believe I don't actually need that, so it can just be copy by value, and so that means it won't be heap allocated, I guess, and because of that, we don't need to like throw when we try and create new things. So like here we threw because we returned that position. So like maybe that will just work. Yeah, so if we look at this, it'll panic. And if we run it, we can kind of see where we got before we panicked. So our first move, we moved to there, we stopped, we then turned, and then we went down just 5 spaces, then we turned, and here we wanted to wrap, so we got to there, and we need to find that point there, I guess. And so that's where we're up to at the moment. So I guess, how do we wrap? We and it's a good thing that the struct worked as intended. I guess like everything is updating, and it's potentially because we're doing this like kind of functional way of kind of updating the position as we do it. And I wonder if this needs to throw anymore. Not that. That needs to throw because we do a format just there, which is frustrating because we're only throwing when we're panicking. Right, so let's go and do this wrapping. So we want to match on position.direction, and like potentially we want to so like the input actually description actually spells it out for you. Like if it would take you off the map, you wrap around to the other side. In other words, if your next tile is off the board, you should instead look in the direction opposite of your current facing as far as you can until the opposite edge of the board, then reappear there. So we basically want to go back until we see either an underflow or overflow, or an out, and then we want to go one less than that. So if we have a right, we will be going, so I guess we could probably have x to be position.x again. Yeah, maybe +1 again. Because I do the minus down there, but then like here I won't want it +1, which is frustrating. What I could do is actually just do this and maybe that and that, and then not worry about that nonsense. So if we're going right, we want to go left. So if x equals 0, we kind of just want to yield, and like, what are we returning here? We're returning our xy, so maybe we can go xy. No, we couldn't do that. We can probably do something like that, and then x equals x and y equals y, and we can just yield x, y like that. And if it is not 0, we kind of want to minus it, and then if dot grid of y and x is out, then we want to yield x plus 1 y with the space there. And we kind of want to continue doing that. So maybe this needs to be in a loop while x is greater than 0, I guess. And then we can just yield x, y. And while x is greater than 0 and dot grid, I don't think we could do that. We can just break in here. so if x is 0, then we'll just yield that. So that those two lines are all good. Otherwise, we want to x minus minus, which might make x 0 in this case, but that's right, and because 0 is still valid. And if that is out, we want to basically plus that back on and then break. Yeah, and I think that's all we need to do for the right case. And if we have left, we want to do similar, but we want to have it while x is less than dot grid of y dot size, and I think -1. And it's probably safer to do a +1 there, just in case size is 0. The -1 will make it -1, which as a u size doesn't exist. And I guess we don't actually have to yield the xy, and so we don't really need to do that, and we don't really need to assign it. So we just set it to start with, and then we go through and do it. So if x plus 1 is the size, that means I think we almost want +2. Yeah, I think we want +2, because then when x is equal to size -1, we're like right on the edge, and we don't want to go further than that. Yep. And then here we want to go x plus plus and have that same check here. And if it is, we just want to go like that. Cool. So up is going to be very similar to the right, except it's going to be with x is, I think, from there. With y's, sorry. And the down, not ground, is going to be very similar to the left, except with y and y and y, and this will just be that. And so I think that is now implemented for that case. So that's like not even the case that would have come up. But I think what we can do is actually just kind of copy paste that and put it here as well. Yeah, I'm like hopeful. I'm like 90% sure. So if we run this, it might just solve the whole thing. That is an aim, I guess. It might also panic. Yeah, so it did some things. It got the wrong answer though. So we can see where it went. So it went down, it went to there, it turned, and so here, I think I want it to print it every time it does a step, I guess. So that's in steps. We can go like this, and I guess, yeah, just here, and grid exist. So if we do that, then we should be able to kind of see it step by step, day by day. So if we do less, yeah, so we can see it stepping, we turn, we go down, maybe this is too slow, but that's alright. So we should get to here, then we should turn, we print it once for the other thing, then we turn, and then we go there, and we should go, that looks right, and we should just go there, but we go one, oh, where did this take us to? Yeah, so it takes, this is weird. So it takes us just below the this one. Yeah, so at this point here we should be wanting to turn. It prints that again, so we turn and then we go down a couple and then we stop, and I think it's like trying to push against the wall a bunch of times, but it still thinks we're there. Yeah, so then we do a little turn, and I think at this point we should be turning. Yep, so we do a turn, and then here we should kind of appear at the top. We're not moving, so yeah, it's not finding that upper, so that is when we're facing down, we are facing down, and the next thing is out. So this square here should be an out. It's printed as a space, which makes me know that it's an out. So we're basically in this case, but we're in here, so like in this one. So maybe I can go panic here, and if we run that, and like you can't do inline if, so like that won't do it. You really need to do that brace, which means that you need to find the end of the line, which in Vim it's kind of easy, but yeah. So I think this should only panic when we get to, yeah, so it even like printed out. Interesting, it printed out actually. Right, so it printed there because it's also trying to do that. Yeah, we should just get none there. But yeah, so here we have, maybe we can print out some outputs. Print line, wrapping down y equals that, and dot grid dot size equals that, and y can be that, and dot grid dot size can be that. And I kind of do want to panic. If 1 equals 1, just panic. I think you need a string for my little panic, but I also don't know. Right, so I might add some other things. Don't do that. Right, so if we run this, we are wrapping down, we're at 7, so like that 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, that makes sense, and we can go down to 12, 8, 9, 10, 11, so 12 would be off out, so I think it might need to just be 1, but in reality, I think these up and down are going the wrong way now that I look at it. Because when we're going right, we're actually going left, and when we're going left, we're actually going right, and when we're going up, we want to go down. And when we are going down, we want to go up. Like that. And then I guess these two... Oh wait, that's not what I wanted. I wanted that, and here we can just do that. And basically, what it was doing, it was going up to find probably that space, and then saying we're there. And no, we were going from here down, and so it was like you should stay there. And when we were here, we were trying to go down, and it was like, yeah, you should just stay there. But in reality, we wanted to look the other way. And now we do. So this should hopefully get us to the end. We get an answer. It's not the right answer, but we are in the right spot, which does make me wonder. Maybe when we print the answer, we can also print just position like that. And I kind of like this little graph thing. So yeah, we went down, we should try, and then we go across, and then here we go down, and we get there, and then we can't go anywhere, and then we turn, and then we go, and we get this last one. And I think I see the issue is because they're saying rows start at 1, columns start at 1, so they have a 1-based system. The facing is right, I think, so it being right means it's like adding 0, not anything else, but we're off by 1 there. So what I can do is get rid of that, and in our password, which is ridiculously high up, we can add 1? No, subtract 1. Yeah, we want to add 1. I feel like that would get us too high, because yeah, it wants us to, yeah, we need to subtract, but then that runs into an issue, like what if we, is this even, right, so 0, 1, 2, 3, 4, 5, so y is 5, and 0, 1, 2, 3, 4, 5, 6, 7, and x is 7. But because that is actually 1, I guess they're suggesting, because that's 1, that means that's 8. Am I misreading things? Yeah, final column is 8. So do I have, yeah, alright, we've got 2 bugs here. 1,000 times the row, so that's actually going to be y, and it's going to be plus 1, and then this is going to be x. And I think this will be the right one, which if it is, it will just not show this stuff, but it'll still show the map. Which I'm happy the map is doing the right thing, so what I might do is remove that from there and remove that from there. And so we didn't get the output in there, but that means it failed because we Well, it says we failed because we printed our output that is not expected, but we did get the right answer. Did we not save that after doing that? So if we run that again, it should get the right answer and say pass, which means that I can take off the example and it should crash. Always good that. So I guess what I want is actually to get in that code again and maybe compile this again, but let it crash again, but then we can see why it's crashing. It's a big map. I like how it's crashed before it has even printed out. I suppose it saved it to a file and now it's doing a diff on it. But yeah, so if we do this and maybe go here, so it reckons index is less than the size. So do we have like little guy somewhere? It should be bolded. I kind of want to make it a color as well to just find it in this. So maybe if I, okay, I think my terminal crashed like that before. Advent of code, and if we do say a git grep of that one, we can go 31. Yeah, that will probably do a thing, and that killed Hack Studio for me as well. So Hack Studio, maybe we'll just full screen that, and maybe here we can search for where we do that, and what do I reckon? I didn't want to open that again. We can do that. 31M, 31M. And here if we maybe jakt day 22.jakt and just run that build script. Not run it under the test harness because that doesn't really, it's not like super useful for when it crashes. Right, so I saw like snippets of red things here. Right, so we can't like full screen it when it's like about to crash. Can we like full screen it now and just run it and like hands free, see what it happens, because I want it to print it all out and then kind of see where things are, because right, so it's crashed there. Hopefully it doesn't crash again, and be on the lookout for a red error somewhere. Not seeing a red error anywhere. Another thing I could do to make it easier, which maybe I'll do that, a22.jakt. If we search for this one, we can just not clear it once we printed it, so then it will like just be red the whole way. But yeah, maybe we want to clear it at the end, so yeah, maybe I'll go back here and clear it there just in case. So after every map it will print the bottom half as red, and the very first character that is red will be the one that we want. So we can run this again. So there's snippets of white, so at the start it starts at the top, but eventually it should go down and get to the right place. So there's like more white, maybe. Wait, no, I don't want to say we backtrace things. Hopefully that is fine. Yeah, so it reckons we are here. Right, so we're facing down, and I guess that means that, yeah, we're facing down and we're trying to, like, go over the size of the thing. So I kind of want Hex Studio open again, and not have my terminal crash, but we'll see how we go. So we are facing down, and I guess yeah, so maybe we can go print line. We're only really looking at Y. That and size equals that, and we can print out our Y and grid size. And I think what I want to do is uncomment that. We can keep it red, and maybe remove that, and maybe remove that. So basically we're not printing it out, and my idea is, what do I want to do? I want to just compile it, then run it. Alright, we're on 4 now. Yeah, so we've got one single print here, and I'll move that down to kind of see where it fails. Not there. So that means this case shouldn't happen. So here we can probably do it again. Like so. And that had one less. So we had 51. Except no, we had +1, so that starts at 0, and then that started at 1, now it starts at 0, and it goes up to 50, and it had 150 printed, which seems legit. So maybe we can do it inside of this, and it shouldn't print at all, but if it prints at 50 before the fail, that kind of shows that's where it's crashing. Inside of that if thing. It never prints it. I wonder, yeah, I wonder, x equals this, and y size equals that, and x size equals that, and maybe do x and dot grid of y dot size, and run that one. Yeah, so it's doing a thing where it went overbound that way. Yeah, so x size is not good. So I guess yeah, I guess what's happened here is maybe if we did that, I wonder if that will work or not, because yeah, at this point here where you kind of want to, well, it goes 150, but then here it's just 100, and so here we should be like, nah, I think it will just fail somewhere else. It printed more things, maybe. Yeah, I think it anecdotally printed more, because it kind of goes up to 50, but then here it does some things. It goes up to 49, and then it's like, nah, I can't do that. But then it wraps around, I guess, and at which point it now fails again on a similar thing after the fact. Yep, it's kind of annoying that it doesn't say what sizes we're talking about, but what I'm imagining is maybe if we print our direction dir equals that, and that is just like position dot direction. See how that goes. And if we run that, right, so we're going up, and I suppose we can't go up. Yeah, because we're going up, we're going down looking for a thing. So maybe we can copy this and do it in here. And maybe just right here, just so we know that it's that one, and it'll pad it out slightly. Right, so I never did the here there. We are going up. Right, so print find thing equals and dot grid y x. I wonder if I didn't compile. No, I think I did. So it's a floor where we currently are. So that means it's not and out, so I guess it's not failing there. And so it just returns the position, and we got yx. So I guess this is happening at a different time. Maybe we can call it first. So it's probably happening up there. Yep, so it happens at that first. So we're going up, so we'll be going down, and so we must just go down the whole way. So here we can probably just print here and run this again. Right, so we go up to there. I think I want this after the must be like a kind of weird map where I guess I can, if we go inputs and a 22 dot example, I think kind of what's happening here is it's got some in fact like it's basically got some overlapping there, but there's no padding here, like this doesn't go up and like this doesn't go up. So we need to detect when that happens. So yeah, here we kind of go over a thing and X can only go up to 100 there. Here I think we need to go if x plus 1 is greater than grid y dot size or that thing, potentially might not work. The compiler doesn't like that sort of nonsense. So gosh, we'll go back down there and here we'll just do the same, and we'll probably want to do a similar thing for all of them, but yeah, I think if this works, it works. If it doesn't, it doesn't. Right, so there it got like a different place. So I think I just need to kind of fix all of those things. For now, I think I'll leave that as is, and I'll come back to it potentially in. Hello and welcome back to the same video. So here we were having the issue that the grid wasn't like square. So sometimes when we go through, we find that the y, the opposite variable. So like in this case, we were incrementing y, but when we go down to that row, that row wasn't as wide as previous rows, so the x kind of overflowed. So we have to do this additional check. Annoyingly, we can't, like these are identical, but annoyingly we can't kind of set it all in one, because this statement, testing whether an enum is a particular instance of the enum, you can't kind of have additional condition like something there. In jakt, we need that dot. So this is happening somewhere else. So yeah, the x and y should always be valid in the sense that it is above 0. So all we really need to do is check that in all of these we kind of need a similar check to this, but maybe a different kind of case here. And here we want y and dot grid, so something like that. And here we want the same thing but the minus, and here we want the same thing but plus. And I think what we could potentially do is just copy all of that. It's annoyingly the same as this, which kind of makes me think that we could make a wrap function. Wrap. And what this will take is maybe just position. Like all it's really doing is getting the x, y, not really setting the position again. Yeah, so I think this will take our position and it will take a x, maybe we'll have that here. It will take our x, which will be a u size, it will take a y, which will be a u size, and it will return two u sizes, which will just be the u size. And I guess we don't actually need to pass in the x and y because we kind of do it there. So we can probably just do something like this and maybe go back there, and this can be mutable, this can be mutable, and here we can probably just return whatever this match does. Return, actually no, we can just do that match which will do all the stuff, and then here we can return x and y. And in this thing we can t equals wrap position, and then we can just go x equals t dot 0 and y equals t dot 1, and then we don't need any of this, and we can also just copy that down to here, which makes this a lot easier to kind of read. And yeah, like that just fits in one page, and this is a bit longer, but that's alright. And so this kind of does the wrapping for us, depending on that. And so maybe we can see how this goes. Doesn't like that. Is it not? We need to do a let. What I would really want is to just go x, y equals that, but I believe that doesn't work. Yeah, assignment to a mutable variable. Even though x and y is both mutable, it wouldn't like it. Right, so it doesn't. We need to dot this because we do use the grid, so we can just add this here, and every time we call wrap, we just need to do a dot wrap to pass in the objects. Right, so that's compiling, and I think I got all the edge cases there, but you just never know until you run it and you get an answer. And maybe you test that answer here. Have I clicked on it? 29408, 29408, and you find out that is the right answer. So what I can do is outputs day 22 dot output, and we can just put that there. And so if we run tests on 22, we should get a pass for both input and example output. So, I think, yeah, I'll end this video because I'm tacking on to the other video, which was already reasonably long, and